In this week's lab, we will be creating a single degree of freedom model to match data obtained from an experimental setup. The data from the experimental setup will be given to you as a text file. This means the first step is to import the data into MATLAB. So let's run through a small example. First, we need an example.txt file, and lucky for us, I have one right here. And so here's the data that we are going to use. Alright, now to get this data into MATLAB, and before we can do anything else, we need to make sure that the .txt file we want to take the data from is in the same directory as we're currently working in. Which, again, lucky for us, it is. That's why we can see it in the current folder. Alright, so let's work on that script file that we will use to import this data. Alright, so just like normal, we start with clear all and CLC. Alright, so the command we are going to be using to import this data is called load. So we're going to say our variable is called data, and it will be equal to load, and then we put some parentheses and apostrophes, and inside the apostrophes we're going to put the file name of the file that we want to import the data from. And it's very important that you also include the file extension that's at the end of that file name. So for us, that file is example underscore data.txt. And then we'll suppress that. We'll save it as Untitled2 and run it. And then you can see right here that now we have our data in MATLAB. What's important to realize is that right now our variable called data is formatted as a matrix. It has the information from both columns that were in our .txt file, and that isn't very useful for us. So let's make two more variables, one for each column. So let's go back to our script. Alright, and by using these two extra variables, we should be able to use the information more effectively. So the first column is kind of representing our x-axis for our data. So we'll call that variable x. And we're going to set that equal to data. Now we only want the first column from our matrix data. So we use a set of parentheses, which allows us to specify what rows and columns we're going to take. Since we want the value from every row in the first column, we use a colon to represent every row and end it with a comma. And then we use 1 to specify that we want just column 1. So this command means that our variable x will have the same value as the entire first column from our matrix. Alright, let's do the same thing, but with column 2, which we will call y. So we set that equal to data, parentheses. We want every single row in column 2. Alright, let's run it and make sure that this worked. Alright, so if we remember, our first column here is from 0 to 10, and then our second column is 1 through 11. Alright, so when we look at our variables, x 0 through 10, and y 1 through 11. Another command that will be useful this week is the length command. The length command takes one input, which can be any variable, and it outputs the number of elements in the longest dimension. So let's give this a try with our variable y. And if we do this right, we should get the number of rows, which is 11. So we'll just call this points, and that is equal to length with parentheses of y. We'll suppress that. Alright, so let's see what happens when we run the program. And we can see right here, we got 11 for our value with points. The last command we need to go over is the sum command. The formal definition is given as, it returns the sum of the elements along the first array dimension whose size does not equal 1. So, in a more basic sense, if you have a vector like we do in our case, it sums the entire column. So, let's again apply this to our variable y. And we will call this total, and it will equal the sum, parentheses, of y. And we'll suppress that. Now, if we did this correctly, we should get the number 66. So let's run our program. And you can see here, we got the value of 66 just like we should. Given all of these commands, you can use them to evaluate your data in various ways. Just for fun, let's take the average of the vector y. So, to do that, we can just take the sum of y and divide it by the number of points it has. Now, lucky for us, we already have both of these values. So all we have to do is say our variable is average, and that is equal to total divided by points. Alright, now this should come out to be 6. So let's go ahead and run it. And we can see right here, we got our average of 6. So, using the commands covered in this video together like this will be essential to completing this week's lab. So make sure you're comfortable using all these commands in conjunction with one another.